Okay, last video we talked about even and odd degree polynomial functions. This one we're going to talk about some radical functions. Now the main thing to realize about a radical function that will help you understand how these are working is remember that if I have an x square, its inverse, its opposite operation is a square root. If I have an x cubed, its inverse or operation is a cube root. If I have an x to the fourth, its inverse or opposite operation is a fourth root. So these radicals are basically inverses of polynomial functions. So that means since a polynomial function would look like this, a radical function would kind of go sideways. Now to keep it a function, we do have to leave off the part I'm going to draw in green here down at the bottom. Technically, if I drew it sideways, I would have that, but that green part would make it not a function. So we kind of do a restriction to only look at the positive values there. For this next one, I have for x to the third, that looks kind of like that. The radical function looks kind of like this. It just kind of turns it sideways again because that's what the inverse operation does. It switches x and y. So instead of stretching out vertically like the original x to the third, the cube root of x stretches out horizontally. And on that case, you do not have to have a domain restriction because it is a function as is. Now, this will just help us because when I look at these, basically, when I look at radical functions, I'm looking at graphs that are going across the x-axis. And if it is a degree 2, if it's even, it was going to look like a parabola. But once again, we're going to have a domain restriction, so it's only half a parabola. So just like you could look at a parabola to see the minimum or maximum, we can find the endpoint by saying a -1 is going to mean a 1 because you go opposite with what's with x. And then if it's not with x, it just stays the same. So my endpoint is 1, 2. So I'm going to have my graph 1, 2 here. And then it's going to look like kind of half a parabola. Now what this means for your domain and range is that it is undefined for negative values inside the radical, so it does have a domain restriction. For example, if I was to try to put in a 0 for the x, 0 minus 1 would be -1, and so the square root of -1 would be an imaginary number, so I do not have anything on the graph for a value at 0. It literally starts at this endpoint here. Now, your domain based on this endpoint would be that x starts at 1, and since it does touch that endpoint, it's a bracket, and then it's going in this direction toward the positive x-axis, so 1 to infinity. Your range, since it's an endpoint, is the y value of that endpoint and that. So once again, you're going to end up using the values of your endpoint, the x value and the y value, to figure out your domain and range for these even radicals. And if it was a higher power, like a 4 or 6 or whatever, a higher index, it's going to be the same basic idea. Now, when I look at the odd radical function, what I'm going to have with it is instead of an endpoint, it's still going to have a center point. So remember, what's with x is opposite. So that's a -2. And then that stays the same if it's not with x. So -1. And that means I'm going to have a center point of -2, -1. And and then what it's going to look like is I'm just going to have something about like this, where it's going to just kind of be a sideways swoosh or sideways lightning bolt. Kind of looks like a string trimmer, but this time it's turned sideways. The original the x to the third function would have looked something like that. So its inverse will go sideways. In this case, the center point doesn't affect the domain and range because my domain and range are both all real numbers. It's not increasing very fast on my range, but at both ends, this is continuing to go up slowly. This is continuing to go down slowly. So eventually, as you kept going out, it's going to get bigger and bigger and bigger. And it is all real numbers, although it's not increasing very quickly. So those, because they don't have an endpoint, the domain and range is just all real numbers. Now, just like the domain and range for a odd polynomial is all real numbers.